Most of us have clicked through an online personality quiz at some point, quickly checking boxes about how we handle crowds, how we organize our desks, or how often we feel restless. Moments later, the screen provides a specific result. It tells you that you're a high-energy extrovert, or perhaps that you're on the verge of total burnout. But if you look back at the questions, none of them actually asked, "Are you burned out?" or "Are you an extrovert?" The computer calculated those invisible states of mind without ever asking about them directly. Measuring physical things like height or weight is simple, but to see the traits that truly define us, like our temperament or our mental health, we have to rely on a clever mathematical bridge that connects what we do to who we are. In the world of statistics, that bridge is called the common factor model. It is the standard tool used by researchers in psychology, education, and business to turn human behavior into something they can actually measure. The common factor model works like a translator, taking the messy, unobservable parts of the human experience and turning them into clear, actionable data. To understand how this works, we need three basic concepts. First, we have indicators. These are the observable actions we can record, like the specific answers you provide on a survey. Then there is the latent factor. You can think of this as a hidden puppeteer. It's the underlying trait, like anxiety, that is actually causing a person to answer those questions in a specific way. Finally, we have factor loadings. This describes the strength of the relationship between that hidden trait and the recorded behavior. Some actions have a much stronger connection to the hidden factor than others. This chart shows how researchers map this relationship. The circle at the bottom is the latent factor, the hidden cause, and the arrows represent the factor loadings that connect it to the 4 observed behaviors in the boxes above. The entire logic of the model rests on one idea. If you removed that hidden factor, the observed behaviors would lose their connection to one another. Their mathematical relationship would drop to 0. Scientists use 2 different approaches to run this math. The first is exploratory theory for analysis, or EFA. Imagine a researcher with a massive pile of survey data, but no clear idea of what it means. They have thousands of responses, but they don't know which behaviors are related. In this scenario, EFA acts as an explorer. The math sifts through the data to find which questions tend to be answered in similar ways. It groups those related responses together to reveal hidden factors the researcher didn't even know were there. The goal of EFA is to find the simplest possible explanation for the data, identifying the smallest number of hidden traits needed to explain a large set of behaviors. The second approach is confirmatory factor analysis, or CFA. This time, the researcher starts with a specific theory. For example, they might believe that 5 specific questions are the perfect measure of workplace stress. CFA acts like a judge. It takes that theory and tests it against a new set of real-world data to see if the math actually supports the researcher's assumptions. While EFA helps researchers discover new patterns in raw data, CFA is how they rigorously double-check those patterns to ensure they are accurate. While this math powers internet quizzes, it's also the foundation for serious medical and psychological research. Take clinical depression. A doctor can't observe it directly, but they record specific behaviors listed here, like hopelessness, sleep issues, or slowed movement. Because they share a hidden cause, these data points move together. As hopelessness increases, the math shows worthlessness usually increases alongside it. This mathematical evidence allows researchers to confirm that a diagnostic checklist is effectively mapping a real, hidden condition, rather than just a random collection of symptoms. Human nature is too complex to be captured by one single question. By analyzing the patterns across many different behaviors, factor analysis cuts through the surface-level noise to find the quiet, underlying forces that drive us. Every single survey you take or daily metric you track is ultimately a vital signal of something much deeper beneath the surface. Using the common factor model, researchers can trace the invisible strings of our actions back to their hidden source, making the invisible parts of being human finally visible.